This site looks fine. Now watch the same site on a phone on a real network. Nothing for 3 seconds. 6 seconds before the hero shows up, and the layout's still jumping around as the fonts load. Lighthouse score? Not good. And the code is fine. The site isn't badly built. It's just doing too much work to load. In this video, we'll look at common performance issues and discuss techniques to optimize your websites.
Let's start with some quick definitions before we touch anything. First is LCP. How long it takes for the biggest visible thing on the page to show up, usually a hero image, sometimes a headline. Then CLS, cumulative layout shift. I'm sure you've experienced this. You tap a button on a news site, an ad loads, the button moves, and you tap an ad instead. CLS measures exactly that. And the third is INP, interaction to next paint. When you tap something, how long until the page actually responds? This replaced FID in March 2024. FID only measured how long the browser took to start responding to the first tap on the page. INP looks at every interaction. Speed, stability, responsiveness. And every fix in this video tries to improve one of these three. To know which fixes actually work, you have to know what the browser is doing when it loads a page. It's a 5-step process, and most performance bugs are one of those steps getting blocked. Step 1, it downloads the HTML and starts parsing it. When it sees a style sheet, it stops. It can't draw anything until it knows how things should look. So it pauses, downloads the CSS, and parses that. Then it merges the HTML and the CSS into a render tree, what to draw and how to style it. Next, Layout figures out where everything goes, and Paint puts pixels on the screen. Anything that interrupts these steps delays the page. A big CSS file blocks. A regular script tag blocks. A web font with the wrong setting can hold up your text. All this is called the critical rendering path, and almost every performance fix is just a way to stop blocking it. Let's audit the site. DevTools Lighthouse tab. Always set it to mobile, even if your users are mostly on desktop. Mobile devices are slower and have worse networks, so problems show up there first. And run it. Below the score, Lighthouse lists exactly what's slow. Lighthouse warnings usually falls into 4 categories: images, JavaScript, CSS, and fonts. Let's start with CSS. When you visit a page, and that fraction of a second where a page is half-styled, or worse, completely blank when it should be loaded, CSS is the usual cause. CSS is render blocking by default. Until every style sheet in your head tag is downloaded and parsed, the browser will not paint a single pixel, which means your CSS file is on the critical path for LCP, including the rules for your footer and the rules for that modal nobody opened. The classic fix is critical CSS. You take the styles needed to render the visible part of the page, inline them directly in the head, and load the rest in the background. The browser can paint right away with what it has, and the rest of the styles arrive while the user is still looking at the hero. Doing this by hand is a pain. Most teams use a build time tool. Beasties, the maintained fork of the older critters, does this well for static and pre-rendered pages, and some frameworks have ready-made integrations. But there are times when you should skip this. Critical CSS pays off when your style sheet is over 100 kilobytes and your hero is still waiting on it to load. Below that, setting it up isn't worth the pain. Instead, just keep the bundle small. The other big CSS lever, just shipping less of it. If you use Tailwind, this is automatic. Only the classes you actually used end up in the build. For traditional CSS, PurgeCSS does the same thing. And if your pages are long product pages, long blog posts, long feeds, there's a CSS property called Content Visibility Auto. Apply it to sections below the fold and the browser doesn't render them until the user scrolls close. It's like lazy loading, but for layout work. Safari only ships support in late 2025. Older versions just don't get the optimization, which is fine. It's a progressive enhancement.
We've discussed CSS optimization, but on most sites, the heaviest thing on the page is still the images, and they're usually the slowest to load too. Resizing them by hand isn't really a fix, and that's exactly where today's sponsor, ImageKit, comes in. ImageKit is an image and video API with digital asset management that lets you store, transform, and deliver optimized media. Around 300,000 developers use it, and the free plan is genuinely enough for most side projects. You can either use their inbuilt media storage or use native integrations with cloud storages that you're already on, S3, Google Cloud, Azure. There are over 50 URL-based transformations that you can apply to images and videos just by changing the URL. Resize, crop, watermark, AI smart crop. Same idea for video, HLS and Dash streaming, all from URL parameters. And there are SDKs for most stacks, React, Next.js, Vue, Angular, mobile. I'm using Next.js here. Setup is fast. Install the package, npm install @imagekit/next. Then copy your URL endpoint from the dashboard into your env file. In your code, swap Next's image component for ImageKit's. The props are the same, only the import changes. Take this hero image. It's about 4 megabytes. That's a lot for one image on a homepage. I add 2 parameters to the URL, w-1280 to resize it, and f-auto so ImageKit picks the right format for whoever's visiting, AVIF, WebP, or JPEG, depending on what their browser supports. It was 4 megabytes. Now it's 100 kilobytes. And it looks identical. The SDK also builds the source set for you, so phones get smaller files, Retina screens get sharper ones without you having to think about it. And you can use AI transformations to crop, remove, or change background simply from the URL. Let's add FO Auto. And it's not just for images. The same setup works for video too. Adaptive streaming, automatic thumbnails, all from the same kind of URL parameters. So hero videos and product clips are covered too. Free plan link is in the description if you want to try it. 20 gigs of bandwidth a month, no time limit, plenty for a side project. Big thanks to ImageKit for sponsoring. So far we've covered CSS and image optimization. Let's move to JavaScript next, because pound for pound, it slows your site down more than anything else. Then fonts, and finally, how the files get to your users.
An important point you should understand first. 100 kilobytes of JavaScript and 100 kilobytes of image take the same time to download. But JavaScript has to be parsed, compiled, and executed all on the main thread. The same thread that handles clicks and scrolls. So when there's too much JS, you don't just wait for it to load. You wait for it to load, then you wait for the browser to process it, and during that processing, the page can't respond to you. That's where INP scores fall apart. You can address that in 3 ways. First, code splitting. If a component isn't on screen when the page loads, you don't need it in the initial bundle. Switch to a dynamic import, and the chart library doesn't load until the user actually scrolls to the chart. Most frameworks have a built-in way to do this. The syntax varies, but the idea is the same. Second, your script tags. A plain script tag is the worst case. The browser stops parsing your HTML, downloads the script, runs it, then continues. Every one of those in your head adds delay. Adding defer fixes it. The HTML parses to completion, then your script runs. There's also async, which downloads in parallel and runs whenever it's ready. Useful occasionally, but for almost everything you'll add to a real app, analytics, tracking, third-party tags, defer is what you want. Just add defer to every non-critical script tag and move on. And third, actually look at what's in your bundle. Run a bundle analyzer, and likely you'll find something you imported once and forgot, or a heavy library doing one tiny job. Moment.js is the textbook case. Around 70 kilobytes gzipped just to format a date. Day.js does the same thing in 2, a 35x difference on something you don't think twice about. Both install in 5 minutes. If you've never run one against your own bundle, I strongly recommend doing so. All 3 ways boil down to the same thing. Ship less JavaScript. Bytes that aren't in the bundle can't slow anything down. Fonts have 2 ways of going bad. Foyt,
flash of invisible text, where the browser hides the text entirely until the font loads.
The page looks broken for a second, and FOUT, flash of unstyled text, where the text appears in a fallback font, then swaps when the custom font arrives. That's a flicker, but at least the content is readable the whole time. Most likely, you'll prefer the flicker. Add font display swap to your @font face rules, and you get FOUT instead of FOIT. Where your fonts come from matters too. Google Fonts is convenient, but the request goes to 2 different domains, one for the CSS, one for the file, and each one needs a fresh connection. Self-hosting the WAF2 file in your own project skips both. The font shares your existing connection, and there's no third-party site to depend on. Whatever weight your hero text uses, preload it. This tells the browser to start fetching it the moment it parses the head, instead of waiting until the CSS asks for it. Watch that cross-origin attribute, though. Fonts always needed unpreload even when self-hosted. Without it, the browser downloads the font twice. And there's also an easy win. If you use multiple weights of the same typeface, you're probably shipping more than you need to. A variable font is a single file that contains every weight. It's usually about the size of 2 static weights, which means if you ship 3 or more weights right now, switching to the variable version is a free win. Last thing, most font files contain glyphs for languages your site doesn't use. If you're shipping in English, you don't need the Vietnamese glyphs. A tool like Glyphhanger strips them out. It saves a lot on bigger fonts. You can do everything we've covered and still be slow if your server is in one region and your users are everywhere. A CDN puts copies of your static files, JS, CSS, fonts, images, on servers near your users, so the bytes don't have to cross an ocean. And once you're on a CDN, you usually get HTTP2 and HTTP3 for free. HTTP2 lets the browser send many files through one connection. HTTP3, built on Quick, keeps that connection alive when a user switches from Wi-Fi to cellular. Neither one needs a code change. Now, caching for the second visit. The cache control header tells the browser how long it can hold a file before checking again. For files with hashed names, anything that looks like app A3F9C2, the right setting is max age 31,536,000 immutable. Change the file, the hash changes, the URL changes, the old cache is thrown out automatically. Webpack, Vite, Rollup all do this by default. You usually don't have to do anything. Compression. Make sure Brotli is on. It's around 15% smaller than gzip on JavaScript and CSS. Every modern browser supports it, and it's enabled by default on most CDNs. You can do this quick check. Open your network tab and look at the content encoding response header. If it says BR, you're set. If it says gzip, that's an easy win. And one more, Preconnect. If your page makes requests to a third-party domain, an API, an embedded video, an analytics service, add a Preconnect link in the head. The browser does the DNS and TLS work in advance. By the time the real request fires, the connection's already open. Before you close this, performance work doesn't stay fixed. It erodes if you don't actively guard against it. Which is why you should set up a budget, Lighthouse CI, or any monitoring that fails the build when the bundle gets bigger or the score drops. Without that, every new feature quietly takes you back to where you started. Fix it, then guard it. Thanks for watching, and see you in the next one.